In this lesson, we want to continue to talk about Gaussian elimination and also Gauss-Jordan elimination. All right, so in our last lesson, we learned about the Gaussian elimination and also the Gauss-Jordan elimination. And we saw that we could take a linear system in two variables. We could take the kind of numerical information and set up an augmented matrix. And through these elementary row operations, we could kind of pound our matrix into a specific form. Okay, now with the Gaussian elimination, it's this one over here on the left. This is referred to as the row-echelon form, where you have these ones down your diagonal. Okay, so starting at the top left and then going down at a diagonal. Okay, and then a zero below. Okay, and what this tells you is that you can find out, in the case of where you have your x variable, the coefficients are on the kind of left column and the coefficients for the y variable are kind of next to it. You could say that this bottom row here is 0x plus 1y is equal to whatever this is. Let's just call it d for this video. So let's say this is d. So really you know that y is d, and you can go back up and plug in and find out what x is. So that's our Gaussian elimination. With the Gauss-Jordan elimination, it goes a step further. Okay, so now the matrix is put into something known as reduced row echelon form. So that's where we have these ones going down the diagonal, a zero above and below. And so now directly from the matrix, I can read my solution. What we're going to do today is we're just going to kind of expand on this, and we're going to look at some kind of linear systems with 3 variables. And then in the next lesson, we'll even look at some linear systems with 4 variables. Okay. So I want you to see the kind of row echelon form for this. So you're going to have ones down the diagonal, zeros below, and of course you have to back substitute to get your answer. And then the reduced row echelon form, you have ones down the diagonal, zeros below and 0 above. So with the reduced row echelon form, you get your answer directly from the matrix, this guy on the right. On the left, the row echelon form, you have to do some back substituting. All right, so let's go ahead and start this with kind of an easier example. I am going to warn you that this process does get really tedious. I'm going straight off of what your textbook would show you, which is where you get a 1 in your column first, and then you find your zeros, okay? There are faster methods to do this, and you can use those if you want, but I prefer to go with just what the textbook's going to show you so you don't get confused. And then as we kind of progress, we're going to find some easier ways to do this. All right, so let's go ahead and read this off. We have x plus y plus 3z equals -1. We have 3x plus 3y plus 4z equals -3. And we have -5x minus 3y minus 6z equals 13. So again, I want all my equations in the format of, we have the ax plus by plus cz is equal to d, okay? The reason I want that is I want all my x terms to line up, my y terms, my z terms, and my constants, because when I write this augmented matrix, I want all the coefficients for x to be in one column, all the coefficients for y to be in one column, all the coefficients for z to be in one column, and then all the constants to be in one column. So let's go ahead and set that up. I'm just taking the numerical information only. We know that x has an implied coefficient of 1, y has an implied coefficient of 1, we have a 3, and we have a -1. Then for this second equation, I have a 3, a 4, and a -3. For my third equation, I have a -5, a -3, a -6, and a 13. So let's just copy this. And let me paste that in right here. We know that we want to put a vertical bar here to separate the coefficients from the constants. And then I'm going to wrap this whole thing in some brackets. So the very first thing you want to do, if you're doing Gaussian elimination, you want to get ones going down the diagonal, and you want zeros below. This is faster, right? Because you don't have to go through and keep manipulating the matrix to get it into reduced row echelon form from Gauss-Jordan elimination. I'm going to do both with you. I know it's going to be a lot of time. I know it's going to be tedious, but I want you to get a lot of practice with this. So for the first one, I'm just going to go through and do the Gaussian elimination. We're going to do row echelon form. We're going to back substitute, and then I'll go back into it, okay? And we'll pound the matrix further and get it into reduced row echelon form. So what I want is, in the first column on the left, I want the top entry to be a 1. It already is, so that's going to save us some time. So then I want this to be a 0 and this to be a 0, okay? So the reason your textbook always wants you to get a 1 in your column is because it's easy to use it to get a 0. It's always easy to get a 1, hard to get a 0. So how do I get a 0? Remember, I can multiply any row by a non-zero number, okay, and add the result to another row. So what's going to happen is I got to think about what I can add to 3 to get a result of 0. Well, 3 plus its additive inverse of -3 would be 0. And it's convenient to have a 1 there because 1 times anything is itself. So if I multiply this by -3, I get -3. And then if I add -3 to 3, this is going to be 0. I don't care about any of this stuff over here. I'm only worried about getting a 0 here. So the way we're going to do this is we're going to say, okay, I'm going to multiply the additive inverse of 3, which is -3, times this top row, or row 1. And let me just label these real quick. So this is row 1, row 2, and row 3. So -3 is going to be multiplied by row 1. And then I'm going to add to row 2, and that's what I'm going to replace row 2 with. Okay, so that's what that notation means. And then let me do this one too, real quick while we're kind of working on this. We can do 2 at once. So we have this -5 here. So what would I need to add to -5 to get a 0? I would need to add +5. So I would multiply this top row here by +5. And it's really the same thing. I'm just changing this from row 2 to row 3. And that's what I'm going to replace row 3 with. Okay, so let's go through this. It's a good idea to kind of write these things down on some scratch paper because one mistake here and it's going to kill you, right? You're going to get the wrong answer and you got to start the whole thing over. So -3 times row 1. That's what we're going to do first. So I'm just going to write these answers kind of down here. So -3 times 1 is -3. -3 times 1 is -3 again. -3 times 3 is -9. And then -3 times -1 is +3. So now what I'm going to do is I'm going to add these kind of results. It's just this part right here. I'm now adding it to row 2, okay, the corresponding entries. All right, so -3 plus 3 is going to give me 0. And then I'll have -3 plus 3 again. That's going to be 0. I'm going to have -9 plus 4. That's going to be -5. And then I'm going to have 3 plus -3, which is going to be 0. Okay, so I'm done with this, and I'm done with this. So I'm just going to erase this, and now I'm going to move on to this one. So if I do 5 times 1, that's 5. 5 times 1, again, that's 5. 5 times 3 is 15. And 5 times -1 is -5. So now I'm adding these results, okay, this part right here, to row 3. Okay, if you ever get lost in what you're doing, just look at your notation. It's going to help you keep track of what's going on. So 5 plus -5 is 0. And then 5 plus -3 is going to be 2. And then 15 plus -6 is going to be 9. And then -5 plus 13 is going to be +8. Okay, so this part's done. Now, I've got 1 up here. I've got zeros below. So as I move to my next column, I want this to be a 1. Again, if I'm doing Gaussian elimination, okay, Gaussian elimination, I want 1s down the diagonal and zeros below. I don't care about anything else. In this particular case, I can't just multiply by the reciprocal, okay, because that's what I normally do, right? If I had a 2 in that position, I could multiply that whole row by a half, and a half times 2 would give me 1. But because I have 0 and it's unique, because 0 times anything is 0, what I'm going to do is I'm actually going to switch row 2 and row 3. Remember, we can always interchange 2 rows. So I'm going to say row 2 is going to switch with row 3. And so this is going to change and be, let me kind of write this up here so we keep track. So I'm going to have 0, 0, -5, and 0. So I'm just going to erase this, and I'm going to copy this. So 0, 2, 9, and 8. And then I'll write this in here, what I just did. So 0, 0, -5, and 0. And it's just a good idea to use a lot of scratch paper because, again, one silly mistake and the whole thing is blown. All right, so let's go through now and make this into a 1. I'm going to multiply the reciprocal of 2, okay, which is 1/2, times that entire row. So times row 2. That's going to give me my new row 2. And I want you to think about something. I'm not affecting this to the left because 0 times anything is always 0. So there's no change on this. This becomes what we want, which is a 1. So I really only have to worry about this being a 9/2, and then 8 divided by 2 is going to be 4. Okay, so that takes care of that. All right, so now to complete this row echelon form, I just need a 1 here, and I'm done, right? I can go back and substitute and find my answer. So I would want to multiply row 3 by the reciprocal of -5, which is -1/5. Because -1/5 times -5 would give me 1. So that's what I'm going to replace row 3 with. Of course, 0 times anything is 0. 0 times anything is 0. 0 times anything is 0. So I only need to change this into a 1. And at this point, we've achieved our row echelon form. So we can just go back, substitute, figure out our answer, right? So we can say that since this column here represents the coefficients for z, we would have z, or 1z, is equal to 0. These two guys are 0, so those variables are eliminated. You can think about this as saying you have 0x plus 0y plus 1z equals 0. Well, 0 times anything is 0, so this is 0 plus 1z, which is just 1z, or z equals 0. So now I can start back substituting. If I know z equals 0, I can take these coefficients here. I can just say this is 0x plus 1y plus 9 halves times z is 0, and this equals 4. Well, I know that this is gone, right? 0 times anything is 0. I basically just have this gone, and y is just equal to 4. Y is just equal to 4, so that's pretty easy. And then in terms of x, I know that 1x plus 1y, okay, y is 4, so just 4, plus 3z, okay, z is 0, so I can just say, leave that off. This would be equal to -1. Well, okay, I can just subtract 4 away from each side of the equation and find that x is equal to -5. So x is going to be -5, y is going to be 4, and z is 0. So at this point, if you're just told to find the answer and you want to use a matrix method, you can just do it this way because this is a little bit quicker than going all the way through the process with the Gauss-Jordan, okay? If you want to go through the remainder of this, which we're going to do, what you need to do is you need to get a 0 here, you need to get a 0 here, and you need to get a 0 here. And what that does is it allows us to kind of read the answer directly from the matrix. All right, so let's go ahead and crank this out. I'm going to start off with this guy right here in my middle column. So again, I'm going to use this 1 to my advantage. I'm going to multiply row 2. I'm going to multiply row 2 by -1, which is the additive inverse of +1. I'm going to add the result to row 1. Okay, that's how I'm going to get my new row 1. So let's just go through and multiply -1 times everything in row 2. So -1 times 0 is 0. We have -1 times 1, which is -1. We have -1 times 9 halves, which is -9 halves. And then we have -1 times 4, which is -4. So what I'm going to do now is I'm going to add these results here, this part right here, to the corresponding entries in row 1. So we know 0 plus anything is going to leave it unchanged, so I don't need to worry about that. -1 plus 1 is going to be 0. I know that -9 halves plus 3. Let's do that off to the side in a minute. And then I would have -4 plus -1, which is -5. Okay. So let's work on this one right here. We're trying to figure out what this is going to be. So to get a common denominator, I'd multiply this by 2 over 2. Okay, and I would have 6. Let's just write this as 6 over 2 plus -9 over 2. I know that -9 plus +6 is going to be -3. So this would end up being -3 over 2. So this is done. So let's erase this. So now what I need is a 0 here and here to finish this up. It's actually going to work out pretty conveniently here because we have a 0 here, a 0 here, and a 0 here. So what does that actually mean? Well, remember, if I'm trying to work on things in column 3, I'm going to use this 1 in row 3 to kind of work off of. And what makes it easy is that when I multiply by 0, I get 0. If I add 0 to something, it leaves it unchanged. So what happens is if I want to multiply 3 halves, the additive inverse of -3 halves, times my row 3, in every case, it's going to be 0, 0, and 0 over here. So when I add those to the corresponding entries, nothing's going to change. So the only thing that's going to change is this, okay? So if I add this to row 1 and I replace row 1 with this, I only need to change this, and I'm just going to change it into a 0. It's the same thing here. So if I multiply -9 halves times row 3, okay, for that 1, and then I add the result to row 2. That's what I'm going to replace row 2 with. Once again, these zeros do not affect this, okay, because -9 halves times 0 is going to be 0. Adding 0 to something does not change it. So I'm only going to change this guy right here, and it's going to be a 0. All right. So we can see that we got the same answer by putting our kind of augmented matrix in this reduced row echelon form. We have our 1s going down the diagonal. We have 0s above and below. So we find that x is -5. We find that y is 4. And we find that z is equal to 0. All right, so let's go ahead and take a look at another one. Again, as we work more and more of these, they get easier and easier. So we have -6x plus y plus 7z equals -32. Let me just write the -6, the 1 for the coefficient for y that's implied, the 7, and then the -32. Okay, just taking the information from the first equation. Then from the second one, you have -5x plus 5y plus 5z equals -10. Again, when you see something that can be simplified, meaning everything here is divisible by 5, go ahead and take the opportunity to do that because it's going to mean that you're working with smaller numbers. So if I divide everything by 5, this would be a -1, this would be a 1, this would be a 1, and this would be a -2. So you'd have -1, 1, 1, and -2. Okay, and I can erase that. And then for the last one, we have a -3, we have a 2, we have a 1. Again, that's implied to be 1. And then we have a 1. Okay, so let me put my vertical bar here to separate the coefficients from the constants. And once again, I just want to stress this. This is already written in the format of ax plus by plus cz equals d. If it's not already written in that format, you've got to do that first. Okay. All right, so let's set this up and let's copy this. All right, so let's paste that in. So again, I want this top left entry to be a 1. So the easiest way to do that is just to multiply this first row here by the reciprocal of this number. So again, I can label this as row 1, row 2, and row 3. You don't have to do this, but it's just nice to kind of show what's going on. So I'm going to multiply -1/6, which is the reciprocal of -6, by row 1. That's going to give me my new row 1. Okay. So if I do that, -1/6 times -6 is going to be +1. -1/6 times 1 is going to be -1/6. Then -1/6 times 7 is -7/6. And then -1/6 times -32, let's do that off to the side. So we would have -1/6 times -32. We know that negative times negative is positive, so I can get rid of that sign there. So we'll just erase these. We don't need them. And then 32 and 6, they're each divisible by 2, right? So 32 divided by 2 is 16. 6 divided by 2 is 3. So this is going to be 16/3. All right, so the next thing I want to do is I want to get zeros below this 1. So I want this to be a 0, and I want this to be a 0. So what can I do? Again, I just think about the fact that I have a 1 here already. Okay, I have a 1 there. And the reason you get the 1 first is so that you can work with that. So all I need to think about is the additive inverse of -1, which is +1. Okay, so I would just multiply row 1 by 1, or you can just think of it as I'm just going to add row 1 to row 2. Okay, so what I'm going to say is I'm going to multiply row 1 by 1. I'm going to add the result to row 2. That's going to give me my new row 2. Okay, so all I'm going to do is just add. So 1 plus -1 is 0. -1/6 plus 1 is what? I'm going to write this as 6/6. And 6 minus 1 would be 5. So this would be 5/6. Then for this one, you'd have -7/6 plus 1. I'm going to write as 6/6. -7 plus 6 is going to be -1. So this would be -1/6. And then lastly, you would have 16/3 plus -2. So 16/3 plus, you'd have negative, I'll go ahead and say this is 6/3. So 16 minus 6 is 10, so we can say this is 10/3. Okay, so that's taken care of. So to get a 0 here, again, I use the same concept. I'm going to use that 1 there. And again, the opposite of -3 is 3. So I'm going to multiply row 1 by 3, add the result to row 3. So I'm going to multiply row 1 by 3, add the result to row 3. That's going to give me my new row 3. So 1 times 3 is 3. -1/6, -1/6 times 3 is what? This will cancel with this and give me a 2. So this is -1/2. This is -1/2. And then -7/6, -7/6 times 3 is what? This cancels with this and gives me a 2. So this is -7/2. And then you have 16/3 times 3. The 3's are going to cancel. So this will cancel with this and I have 16. All right, so let's add now. 3 plus -3 is 0. So let me erase this. We'll have -1/2 plus 2. So -1/2 plus 2. So let me do plus 4/2. So this would be what? 4 minus 1 is 3. So this would be 3/2. So 3/2. Okay, so this is gone. Then -7/2 plus 1. Let's add 2/2. -7 plus 2 is -5. So this would be -5/2. And then lastly, you would have 16 plus 1, which is 17. Okay, so this is 17. All right, so now we have the first column done. And we're going to move into the second column here. And again, I always want to start by getting a 1. I get the 1, and then I can get the 0 above and below pretty easily. So to get the 1, I just multiply row 2 by the reciprocal of this 5/6, which is 6/5. Okay, so 6/5 times row 2. That's what I'm going to replace row 2 with. All right. So we know that this guy to the left isn't going to be affected because 0 times anything is just 0. Okay, but this guy is going to be a 1, so I don't really need to worry about that. I really just need to do the calculations for these two. So I would have 6/5 times negative 1/6. Okay, so this would cancel with this and give me a negative 1/5. So this would be negative 1/5. Let me erase that. And then lastly, you would have your 6/5 times 10/3. We know that this would cancel with this and give me a 2. And this would cancel with this and give me a 2. 2 times 2 is 4. So this would be 4. So now we want to get a 0 above and below this 1. So again, I'm thinking about the additive inverse of negative 1/6. So that's going to be 1/6. So let me multiply row 2. Let me multiply row 2 by 1/6. So 1/6 times row 2, then plus row 1. This is going to be my new row 1. Okay? So again, to the left of this, it's not going to matter because 0 times anything is 0. 0 plus anything is just itself. So I really need to just think about, I know that this would turn into a 0. So I really just need to work on this negative 1/5 times 1/6. Okay? And then I'll add this result to this negative 7/6. So I know that this would be negative 1 over 30. So negative 1 over 30. And then plus negative 7 over 6. So I'll multiply this by 5 over 5. Negative 7 times 5 is negative 35. So you would have negative 35 over 30. And negative 1 plus negative 35 is negative 36. So let's say this is negative 36 over 30, which is what? Each is divisible by 6. This would be negative 6 over 5. So I'll replace this with negative 6/5. And one more. Okay, we need to do one more. So let me write that a little bit better. Now, I also need to multiply 4 by 1/6. So 4 times 1/6. This would cancel with this. This would be a 3. This would be a 2. So this would be 2/3. Okay, so 2/3. And then add that result to 16/3. Okay, so 16 plus 2 is 18. 18 divided by 3 is going to give you 6. And let's get this guy to be a 0 now. So I'm going to multiply row 2. I'm going to multiply row 2 by what? Again, I want the additive inverse of this, so negative 3/2. Then plus my row 3. That's going to give me my new row 3. I know that I don't need to really do anything this way because I'd be multiplying this by a 0, and that's going to be 0. And then adding it to this would leave it unchanged. So really, I just need to change this into a 0 because I know it would be 0. And I need to work on this one and this one. So I would multiply negative 3/2 times negative 1/5, and that would give us 3/10. Okay, and then I would add 3/10 to negative 5/2. So 3/10 plus negative 5/2. Multiply this by 5 over 5. So this would be negative 25. Negative 25 over 10. Okay, over 10. So negative 25 plus 3 is negative 22. So you would have negative 22 over 10. So this is negative 22 over 10. And then lastly, I'm going to multiply negative 3/2 times this 4. Okay, that's going to cancel, give me 2. Negative 3 times 2 is negative 6. So negative 6. And then add the result to 17. That's going to be 11. What we want to do now is get a 1 as this entry here. Okay, so how do we do that? We multiply row 3 by the reciprocal of that guy. So I'd have negative 10 over 22 times row 3. Again, that's going to give me my new row 3. So we know that this would be a 1. We know that this would be a 1. And we can just eyeball this and say that I know that 11 would cancel with 22, right? 22 divided by 11 is 2. So let's just erase this. This would become a 2. And negative 10 over 2 would be negative 5. Okay? So at this point, you have row echelon form. You have 1s down the diagonal. Okay, let me highlight that. So 1s down the diagonal. You have 0s below. Okay, so that's row echelon form. This is what we get from Gaussian elimination. But we're going to continue with the Gauss-Jordan elimination and put this in reduced row echelon form. So I want a 0 here and here. Again, it's not that hard because we're almost there. Okay, I know this is very tedious, and that's just because we're taking our time. So for this guy right here, this negative 1/5, I can make it into a 0 by multiplying row 3, okay, row 3 by 1/5, add the result to row 2. So 1/5 times row 3 plus row 2 would give me my new row 2, okay? So I know I don't have to work this way, right? I don't have to worry about that because if I'm multiplying a 0, okay, in each case here, by this number, I get 0, and then if I add 0 to something, it stays unchanged. So I really don't even need to work on this one because I know it's going to be 0. I just have to work on this one, okay? So that makes it kind of quicker. So it's 1/5 times this guy right here, which is -5. That becomes -1, okay? And that gets added to 4, so that is 3, okay? So now the last one, we're going to multiply row 3 by 6/5, okay? So by 6/5. And we're going to add the result to row 1, and that's going to give us our new row 1, okay? Now again, when I think about this, I don't need to do anything this way, okay? I know I'm going to replace this with a 0, okay? And I just need to work on this one. So 6/5 times -5, 6/5 times -5. This would cancel, give me -1, so it's -6. So -6 plus 6 would give me 0. So now I have my solution finally, okay? So I can say that 1z equals -5, or z equals -5. I can say that 1y equals 3, or y equals 3. And I can say that 1x equals 0, or x equals 0. All right, so let's continue with the next example. So now we have -4x plus 7y minus 3z equals 33. So -4, we have 7, we have -3, and we have 33. Then we have -7x plus 6y minus 5z equals 19. So -7, 6, -5, and then 19. And then we have -5x plus 2y minus 4z equals 2. So -5, 2, -4, and 2. Okay, so let me put this bar here, and then let me put these brackets, and we're ready to go. So let me copy this. Let's go down here to a nice fresh sheet. And again, we want 1s down the diagonal. We want 0s above and below. Okay, so I'm going to start by getting a 1 in this position here. And to do that, I'm just going to multiply the top row, or row 1. Let me label these real quick. So row 1, row 2, and row 3. I'm just going to multiply row 1 by the reciprocal of -4. So I'm going to do -1/4 times row 1. Okay, that's what I'm going to replace row 1 with. Okay, so -1/4 times -4 is going to be 1. Then -1/4 times 7 is going to be -7/4. So -7/4. Then -1/4 times -3 is going to be +3/4. And then -1/4 times 33 is going to be -33/4. So -33/4. Okay, so that part's done. So now I want to get a 0 here and here. So let me start with row 2 and getting a 0 here. So again, because I have a 1 here, it makes it easy to get a 0 here, because I can just say, okay, I want to add a 7 to this -7 to get a 0. So I can multiply this top row, or row 1, by 7. So 7 times row 1. And then I can add that result to row 2. That's going to give me my new row 2. And this is going to be a 0. Okay, so this would be 0. And then for this guy right here, I would have 7 times -7/4. So 7 times -7/4. And then I would add that to 6. So when that's done, I'm going to add that to 6. So this would be -49/4. And then if I added that to 6, I would make this 24/4. So this would end up giving me -25/4. So I'm going to put -25/4. Okay. So now I want to do 3/4 times 7 and add the result to this -5. So this would end up being what? It would be 21/4. So 21/4 plus -5. So I could make this -20/4. And 21 plus -20 would be 1. So this would be 1/4. Okay, so I'll erase this and put a 1/4 here. So let's erase this. And then lastly, I have this -33/4 times 7. And then plus 19 when that's done. So this would end up giving me -231/4. So -231/4. And then I'm adding to this 19. Now, what I can do to get a common denominator, 19 times 4 is 76. So I can say this is 76 fourths. So negative 231 plus 76 is going to be negative 155. And this is over 4. Okay. All right, so that part's done. Now we're going to do something similar for this right here. So I would multiply 5 by row 1. Again, think about that 1. 5 times 1 is 5. Add that to negative 5, you get 0. And I would add the result to row 3. Okay, so that's going to give me my new row 3. So if I do this one would be 0. Then I would take negative 7 fourths and multiply it by 5 and add the result to 2. So this is going to end up giving me negative 35 fourths. And then plus, instead of 2, I'm going to write 8 fourths. So negative 35 plus 8 is negative 27. So this is going to be negative 27 fourths. That's going to go right here. So negative 27 fourths. Okay, the next thing I want to do is take 3 fourths. So 3 fourths and multiply it by 5. And then add the result to negative 4. So this is going to end up being 15 fourths. Okay. And if I add this to negative 4, let's write this as negative 16 over 4. So 15 plus negative 16 is negative 1. So this will end up being negative 1/4. Okay, so negative 1/4. And then lastly, what I want to do is multiply 5 by negative 33 fourths. So negative 33 fourths times 5. That's going to give me negative 165. So negative 165 over 4. And then plus 2. Again, I'm going to write that as 8 over 4. So negative 165 plus 8 is negative 157. So this is negative 157 over 4. And let's move on now. So the next thing I want to do is get a 1 here. Okay, I always want to get a 1 first and then get my 0 below and above in this case. So I can do that by just multiplying row 2 by the reciprocal of that. So I would have negative 4/25 times my row 2. That's going to give me my new row 2. Okay, so this is not going to be affected. This will turn into a 1. Okay, this will be a 1. And then this guy right here, you'd have 1/4 times negative 4/25. So what's going to happen is this will cancel with this. I'll have a negative 1/25. Okay, and then let me erase this. The last thing I want to do is I want to take negative 4/25 and multiply it by negative 155 over 4. So this is going to cancel. And you'd basically have this negative times negative, which would give you a positive. Between 155 and 25, you have a common factor of 5. So this would be 5 here, and this would be 31 here. Okay, so this right here is going to be 31/5. So let's erase this. So now we're done with that. And now I want a 0 here and here. So to get a 0 here on the bottom, I would multiply row 2 by 27 fourths. Okay, so 27 fourths times row 2. And then plus row 3. That's going to give me my new row 3. So again, I don't need to worry about this stuff over here. For this one, I know this is going to end up being a 0. So I'm really going to only have to work with kind of this part right here and this part right here. So I would have 27 fourths times negative 1/25. I'm going to add that to negative 1/4. So what's going to happen is between 27 and 25, there's no common factors other than 1. So really, I'm just going to say this is negative 27 over 100. So negative 27 over 100. For this, I could multiply by 25 over 25. So I'd have negative 25 over 100. And that's going to give me what? This would be negative 52 over 100. Okay, so let me erase this. And we can simplify this before we write it. 52 divided by 4 is 13. And 100 divided by 4 is 25. Okay, so I'm going to write this as negative 13/25. And then lastly, I want to do 27 fourths times 31/5. And then add that to negative 157 fourths. So 27 times 31 is 837. So this would be 837 over 20. So 837 over 20. If I multiply this by 5 over 5, I would get negative 785 over 20. So if I do this addition, 837 plus negative 785, I'm going to get 52. Okay, so I would get 52 over 20. 52 over 20, which is going to simplify. Each is divisible by 4. 52 divided by 4, again, is 13. 20 divided by 4 is 5. So this guy right here is going to be 13 fifths. Okay? All right, so let's work on this and getting a 0 here. So again, I want to multiply row 2 by 7 fourths now and add the result to row 1. Okay, that's going to be my new row 1. And so I already know that this is going to be a 0. Okay? Then you would have 7 fourths times negative 1 over 25. Add that to 3 fourths. You scroll down a little bit. I'll come back up. So this right here would be negative 7 over 100 plus, if I multiply this by 25 over 25, I would have 75 over 100. Negative 7 plus 75 is going to be 68. So this would be 68 over 100. Which would simplify. 68 divided by 4 is 17, so this would be 17 over 25, right? Because 100 divided by 4 is 25. So this would be 17 over 25. So 17 over 25. And then for this one right here, again, we're going to multiply 7 fourths times 31 fifths, and then plus negative 33 fourths, okay? So 7 times 31 is 217, so you'd have 217 over 20. So 217 over 20, and I'll multiply this by 5 over 5. So this would be negative 165 over 20. So 217 minus 165 is going to give me 52. So I'd end up with 52 over 20. So 52 over 20. And we already know this is going to simplify to 13 over 5. Right? Because 52 divided by 4 is 13, and 20 divided by 4 is 5. Okay? So I'm going to replace this with 13 fifths. So now I want to move on to this column, and I want to get a 1 here, okay? So how do I do that? I multiply row 3 by the reciprocal of this. So I would take 25 over 13, the negative of that, multiply it by row 3. That's my new row 3. Again, this one and this one are not going to be affected. This guy is going to be a 1. And then this guy right here, I'd have negative 25 over 13 times 13 over 5. The 13s are going to cancel. Negative 25 over 5 is negative 5. So this is negative 5. And at this point, again, you could stop. You have row echelon form, okay? So you could go back and substitute. You know z is negative 5 at this point. You could find out x and y. But we're going to continue. We're going to get a 0 here and here. Okay, so what I want to do to make this into a 0, I want to use this 1 here. The additive inverse would be 1 over 25. So times this row 3. And then plus row 2, okay? So I know that I don't need to worry about this or this because multiplying by 0 would leave a 0, and then adding 0 to that would leave it unchanged. This guy I know is going to be a 0, so I really only need to work with 1 over 25 times negative 5, and then plus 31 fifths, okay? So I know that this would cancel with this and give me a 5 here, so this would be negative 1/5. So this would be negative 1/5, okay? So plus 31 fifths would be 30 over 5, which is 6. So this is 6. So we know z is negative 5, and we know y is 6. Let me just write that as we're doing this. So we know z is negative 5. We know y is 6, okay? Now, let's find out x. So what we're going to do is get a 0 here. So again, I'm going to use this row 3 with this 1 in it, and I'm going to multiply row 3 by the additive inverse of this, so negative 17 over 25, so then plus row 1. That's going to give me my new row 1, okay? So I know that this guy and this guy are not going to be affected, okay? This guy is going to be a 0. All I need to do is figure out this guy. So it is negative 5 times negative 17 over 25, and then plus 13 over 5. Okay, let's find out. So this guy would cancel with this guy and give me a 5. Negative times negative is positive. So let's just get rid of that and say this is 17 over 5 plus 13 over 5. That's 30 over 5, which is 6. Okay? So this is 6. So x is 6, y is 6, and z is negative 5.